One. Make sure you check your email, sir. Okay, all right. We could do that, right? And then in the past, we've actually done like partial fraction decomposition on this. Remember when we did that? And it split it up into two pieces? We did this when we were integrating rational functions. What if that helps us? I mean, it doesn't seem like it would, but let's try it. Let's just see. Let's just see what happens, and something really actually kind of amazing is about to happen. So I'm going to do partial fraction decomposition. I want to turn 1 over n plus 1 times n minus 1 into, well, I have two distinct linear factors. So a over n plus 1 and b over n minus 1. And then we go about the task of figuring out what a and b are. So I go 1 is equal to a times n minus 1 plus b times n plus 1. This all look familiar?
Yeah, it's going to be harmonic afterwards.
And then let's say, let n be negative 1. If I do that, that'll kill off this one. So let's let n be negative 1. This equation turns into 1 equals a times negative 1 minus 1. Isn't that just negative 2? And then divide through, so shouldn't a be negative a half? Good. And then to get b, we could let n be 1. Same game. Kills this one off. I get 2b, so b is a half. All right. We could do that, right? I mean, that's just algebra. We can take that expression, split it up into two. Let's see if that actually helps us at all. So coming back over here, if I rewrite this, it now can be written as a over n plus 1. A was negative 1/2. So I'm going to write negative 1/2 over n plus 1 plus b, which is a half, over n minus 1. That should generate the exact same series, shouldn't it? Algebraically, that's identical. Okay? Now, each one of these individually is what? What is this? Constant over linear, constant over linear. Individually, they are harmonic, right? But I just put a theorem up that said if individually they're divergent, that doesn't mean that together they're divergent. So the answer is not that this diverges.
It can.
What's that?
But it can, right?
It could. It depends on what's going to happen here. Yes. So it doesn't have to, though. Mm-hmm. All right? So what we need to do is do a little more investigation. All right? But we're on the right track. So now what I'd like for you to do is I'd like for us to take some time to write out the first few terms again. But they're going to look completely different, aren't they? Let's rewrite this. Tell me what would happen if I plug in, I'm going to write really small here for a reason. What would happen if I plug in 2? Because we're going to start at 2. I get negative 1/2. I need a little more. Negative 1/2 over what? 3 plus 1/2 over, plugging in 2 here, over 1. Right? That's what I get first. Plus, okay, what would happen if I plug in 2? I'm sorry, 3. I started at 2 already. This was 2 going in. 3 into here. Negative 1/2 over 4 plus 1/2 over 2. So far, there's really nothing happening that's kind of glaring out at me yet. Let's just keep going a little bit. Next one. Negative 1/2 over 5 plus 1/2 over 3. Do you see it now? Do you see what's happening? Well, do you see, you just said, or don't they start repeating and canceling? Do you actually see any canceling happening yet? Yeah. Do y'all see this first one right here? It actually showed up over here now? And they're opposite in sign. Like this is negative 1/2 over 3. This is positive 1/2 over 3. So those are actually going to go away. Let's go a little bit further. Let's see if this actually continues. Negative 1/2 over 6 plus 1/2 over 4. So look, the 1/2 over 4, hey, it's over here also. opposite in sign. They're going to go away, right? Y'all see it? And this pattern appears to continue. We start to get, I don't know why I did that, sorry. 7, and this is 5. And that one goes away again, right? So what I'm going to do now is just put dot, 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 and I'm going to tell myself, I guess, well, I see a pattern, right? I see something that's starting to cancel. And I'm going to go back to the definition of what it meant for a series to converge. So recall this from when we first started talking about series. Recall that we would say that the sum of some series was equal to S if the limit as n went to infinity of S sub n equals S. That was a definition that we had. Does anybody remember what this was? We had a special name for it. Capital S sub n. No? I'll remind you, see if this S sub 1, S sub 2, S sub 3, S sub 4.
Was it the S sub n plus, or was it the plus or minus one, and then the bottom one also had a S sub n?
If we start with this, if we start with the sequence, right? A sub n, and I say, what's S sub 1? What does that S sub 1 mean? Sum of what, though? Just the first one of these guys, right? What's S sub 2? Take the first one plus the second one, right? So this is A1. This is A1 plus A2. This one is A1 plus A2 plus A3, right? And so on and so forth. So S sub n is the sum of the first n, right? We call it the nth partial sum. The nth partial sum. If we can find a formula for the nth partial sum and take its limit, then that gives us what that sum is, if it converges. Right now, I can't really do it because remember when we were doing the nth partial sums, as you let n go to infinity, this sum starts to just run away from you. But if we can come up with a formula like the geometric series, we actually were able to nail it down, right? So what I'm going to do now is try and come up with a formula for S sub n for this series. So I have to start over, all right? And on your work, on a test, I would expect you to start over also and write down the nth partial sum. And then once you do it, then you'll take a limit at the very end. And start clean piece of paper here. You just need room wherever you're working on your paper. You just need enough room to write this. So what is S sub n equal to? Well, let's just rewrite everything we just had. I know this is kind of like repeating ourselves, but it was -1/2 over, what was the first one? 3? Plus 1/2 over 1. Plus -1/2, 1/2 over 4, plus 1/2 over 2. Plus -1/2 over 5 plus 1/2 over 3 plus -1/2 over 6 plus 1/2 over 4. And that's going to keep going, right? Dot, dot, dot. But this time, it's not an infinite sum. I'm stopping it. And where am I stopping it? At the nth one, right? So there is going to be a last one over here. What is that last one? You're plugging n into the formula, right? So what's the formula? Wasn't this it? That's that last one, that nth one being plugged in. Now we had already established that there was some sort of pattern in the canceling that was happening, right? And I'm going to get back to that, but I want to talk about the pattern because this is kind of the key to these types of problems, is to recognize the pattern. So I'm going to use some weird language here, just kind of try and follow along with what I'm saying. We have, let's see, does this one go away?
Yes.
Okay, so I'm going to kind of circle this one. This one gets killed off by this one, right? Those two they're gone. So could I say that the first, I'll use guy, all right? The first guy right there, here, the first guy here got killed off by the second guy here. It can be a girl, okay? We don't have to, we can even go like totally gender neutral if you want. No? We're okay? First guy over there, second guy over here, they go away. But notice that the second guy is 2 away, all right? First guy gets canceled out with second guy 2 away. Got it? First guy gets killed off with second guy 2 away. How about the next first guy? This is a first guy, right? This first guy gets killed off by the second guy 2 away. They're gone, right? How about this first guy? Will it get killed off? Okay, this one should be killed off by a second guy 2 away, but where does it live? Somewhere in my ... right? But it's there, isn't it? So this guy's gone. This guy is gone. How about this first guy? Does it get killed off? By something in the ... Yes? Yeah, so what about this one? Why doesn't this one go away then? Why doesn't this one go away? He's a second guy, right? Second guys get killed off by first guys, but 2 in front, right? So in order for this one to get killed off, there has to be one guy, there has to be a first guy 2 away over here to the left. And it's not there, right? This second guy needs to have something 2 away. There's nothing 2 away. This second guy, there was one 2 away. That's why it went away, right? Following that pattern? Okay, now let's pick up the back end of this. What's the one right in front of this one? So here we plugged in n, didn't we? What would be the one right in front of it? We'd plug in n minus 1 into the formula. So what would happen if you plug in n minus 1 instead of n here? Negative 1/2 over n plus 1/2 over, we're replacing the n with n minus 1, n minus 2. And I should put one more, shouldn't I? Why should I put one more in front of this one? Because 2 away, right? Everything is happening 2 away, so we need another one of these. That way we can look back 2. What would go into this one? n minus 2, right? Goes in here. So negative 1/2 over, what is it? n minus 1, and then plus 1/2 over n minus 3. Yeah? Let's see what goes away. This is a first guy, right? First guys should get killed off by second guys 2 away. Ah, and it does, right? So that's gone. Let's try this first guy. First guy gets killed off by second guy 2 away. Uh-oh, there is no 2 away, right? So that guy's going to stay. First guy, second guy 2 away. There is no 2 away. This guy stays. How about this one? That's a second guy, isn't it? And second guys get killed off by first guys 2 in front, right? So is there 2 in front? Somewhere in the ... So somewhere over here, I know this looks like a spaghetti factory, but that one's gone, isn't it? Then this one is the second guy gets killed off by a first one 2 away. There is a first one 2 away in the ... So it's gone. Have I accounted for everything? Yep. I think I have. What's in red is what's left. The idea of this, what do we call these series? Telescopic or collapsing. Okay, so let's think about what we have here. In this sum, imagine that n was really, really big. Then that sum would go way out there, wouldn't it? And imagine it's a bridge. What's happened is that we've got some stuff at the front that's left. We've got some stuff at the back that's left. What's happened to the middle of the bridge? It's collapsed out. Everything is gone, right? Just some stuff on the right side and some stuff on the left side. Collapsing series. Also, old school telescopes, the ones that are like, you know, you look up, right? Whatever, or you look in your neighbor's windows. Whatever you're doing, whatever your sick mind's doing, okay?
Or the stars, you know?
Or the stars, whatever, you know. But you have to use it to, you know, adjust it and get it focused. No? Okay. But those telescopes, right, they have an end on, right, and this end, and then they come together, right? And all you're left with are the two ends. Same idea. If you're wondering where the names come from, that's where the names come from. Telescopic or collapsing series. All right, so S sub n is equal to what's in red? So 1/2 plus 1/4. That's just cleaning those two fractions up, right? Then on the end, plus, I'm just going to write as negative 1/2 over n, and then plus negative 1/2 over n plus 1. And what I have is a nice condensed formula for S sub n that no longer has dot dot dots in it, right? If I let n go to infinity now, this thing doesn't run away from me anymore. All that happens is if that goes to infinity and that goes to infinity, these squash down to 0 and you're just left with 1/2 plus 1/4, right? So now the final result. The sum n equals 2 to infinity of 1 over n squared minus 1 will be equal to the limit as n goes to infinity of my formula for S sub n, which is the limit as n goes to infinity of 1/2 plus 1/4 plus negative 1/2 over n plus negative 1/2 over n plus 1. These two are gone, and you're just left with what? 3/4? 1/2 plus 1/4. So this series converges to 3/4. What do y'all think? Let me just kind of like back up and make sure you understand with these problems. You run your nth term test, nothing happens. It's not geometric, it's not harmonic. In this case, you saw the partial fractions happen. And because of the partial fractions, you're able to rewrite it as two different things. You start writing them out, you start to see some cancellation. As soon as you see that, you scrap it and you say, I'm going to start over. S sub n, you come up with your formula. See, you have to have an end point here. For this to work, you have to have a stopping point so you can see where the canceling occurs and what stays and what goes. Once you have that, you run your limit on it and then you get an answer. This limit might turn out to be infinity. It could be, depending on what's left. It could turn out in a different problem to be something like natural log of n. And then as you let n go to infinity, it becomes divergent. So you would say the series diverges. All right? In the homework problems for this section, for this topic, they actually tell you, find the sum of this, or determine if this collapsing series converges or diverges. So you'll know when you see the problem that it's collapsing. All right? Okay. That's it for that. Those homework problems are kind of fun. I'm going to get in trouble one of these days. I can feel it. You won't always use partial fraction decomposition. There is a problem. The first one that's coming to mind is this one. Just look at that for a second. And let's say this n starts at 1. That does not look, well, it doesn't look geometric, right? Doesn't look harmonic. Doesn't look like partial fractions either, does it? No? Actually, darn it, I wrote it the way that, sorry, I wrote it wrong. I should have wrote it like this. Okay, there we go. So if you get that initially, if you run nth term test on it, You let n go to infinity, you're going to get infinity over infinity, you do L'Hopital, this will be 1, natural log of 1 is 0. So the nth term test goes to 0, which is a failure, right? It's not geometric, it's not harmonic, but it doesn't look like partial fractions. If you start writing out the terms of this, you plug in 1, you get 1/2, natural log of 1/2 plus natural log of 2/3, and you don't really see anything happening. But if you use properties of logs and split it into subtraction, okay, then you start writing out the actual terms, you'll start to see cancel.